Hi everyone, welcome to another Halo Business Intelligence webinar. Today's webinar is entitled BI plus Predictive Analytics equals Predictive Intelligence. My name is Kitty Franklin and I will be your moderator today. You can follow us on Twitter at Halo_BI using our hashtag HolisticBI. We have two distinguished presenters for today's program. Our first presenter is Keith Peterson, Executive Vice President of Halo BI. Keith has led data and analytics businesses for 20 years with companies like Mitchell International and AC Nielsen, where he founded a digital marketing analytics business. Keith has a PhD from Vanderbilt University and specializes in data science solutions for retail, consumer goods, and healthcare. Our second presenter today is Drew Minkin, Vice President of Advanced Analytics for Halo BI. Prior to joining Halo, Drew worked for the Microsoft SQL Server product group, supporting and mentoring leading-edge business analytics at Fortune 100 companies. Drew has been on the leading edge of Microsoft SQL predictive analytics and business intelligence for many years now, and he is also the predictive modeler and was also the predictive modeler and solution architect for Prediction Readmission Insight, the winner of the Microsoft Health Users Group 2013 Innovation Award. So before I turn it over to Keith to get us started, here's a quick synopsis of what we'll be covering today and what we hope you will take away from our session. So here's the problem as we see it. In most organizations, advanced analytics, also known as data science, and business intelligence exist in completely separate worlds. BI does a good job of reporting on what has happened in the past, but lacks the ability to see into the future. Data science can predict the future, but lives in a silo outside the mainstream organization and doesn't make it into the hands of the people who need this information in order to impact the business. In today's session, we'll discuss how progressive companies are coupling the strengths of BI with the power of predictive analytics to create a competitive advantage using predictive intelligence. We'll also give some specific examples of how this is happening, and we'll conclude with a demonstration of predictive intelligence in action. Please use the question box in the corner of your screen to submit any questions you may have, and we'll answer as many of those as possible at the end of the session. Now I'd like to turn it over to Keith Peterson, who will tell you a little bit about Halo Business Intelligence. Keith?
All right, thank you, Kitty, and welcome everyone online today. Thank you for coming. We're going to get started right away. Drew and I are going to take about 40 minutes today to talk about how predictive analytics and BI are starting to come together, the technology and the way that people are using the technology. And then we'll leave some time for questions at the end and a couple of polls. For those of you that don't know about Halo, we're an international company. We have customers in North America, throughout Europe and Asia. We really came out of a legacy of being a company that started by simplifying a lot of the technology that was available for database, warehousing, and building BI on top of that. And what we did was effectively wrapping the Microsoft stack with code and with text around that stack to make it easier to use, to generate ETL, to generate cubes and databases, and ultimately to put a BI on top of that. And now is the next step in our evolution. We're doing the same thing with analytics, but we're doing that in the context of BI, which we really think is critical to making predictive analytics more available to busy decision makers and taking out of the silos that typically happen when we have data science organizations working independently of BI. Now, first thing we're going to do is we want to take a quick poll question. We looked at the people that are attending, and we wanted to ask you for your input, first of all, on just how you're using BI today. So we're going to take a minute to do that.
So the first question we have here, let me see if I can get this to display. Yeah, I think you may have to turn me back to presenter here. Give us a second here. Got a little logistical issue on this end. We'll be with you in just 1 second here. All right, so our first question today is Which best describes your experience with using predictive analytics for decision making? And you can click right on the screen to select one of those answers that best fits you. And of course, the answers there, as you can see, are I'm an expert, I'm a novice, I know enough to be dangerous, or what is predictive analytics? So if you can go ahead and vote, then we'll take a look at those poll results in just a second here. Alrighty, and let's take a look at those results, Keith.
Super. Okay, it looks like we have a broad distribution as we thought. Of course, we have some experts on the line, and we've got a lot of novices, and also those know enough to be dangerous, and about 10% what is predictive analytics. So that's great. What we did is broke out the presentation today. I'm going to talk about some of the core and basic concepts around BI and predictive analytics and use a few examples. And then I'm going to go over to Drew, who's going to get down into some of the real technical detail and some of the sophistication that happens. But at the end of the day, we're all going to be focused on bringing and making analytics more available and easier to use by everybody. Okay, so as a starting point, we want to talk first of all just about context, where we're coming from. And Clay Christensen's really famous book, The Innovator's Dilemma, makes a really great point. It specifically targets what we're doing at Halo and what's happening in other parts of the industry around BI, which is that oftentimes disruptive technologies that bring a lot more capability to people in the world today are simpler and more straightforward approaches than prior ones, which are capabilities that come to overserve the market over time. So you can think about this as an evolution from databases and data warehouses to early stage reporting tools that became more and more complex, large enterprise focused. And what's happened in the past few years is we've had the opportunity through numerous companies to make BI more available to people by making them easier to use, easier to access, and easier to pull data into. And that's really where a lot of innovation comes from in the BI world. It's making it available to all of us. And really from our perspective, predictive analytics, it's just a part of the continuum of BI, but it's a very powerful one. In fact, a number of research organizations have estimated the value of implementing analytics in your organizations, and we typically see quotes like this: and organizations earn $10.66 for every $1 they spend on analytics. It's a huge return on an area, but an area that's typically been kind of arcane and hard for many people to understand. So our focus is to bridge that gap. We're going to talk about that today. First of all, our perspective on the role of BI. So most of you are probably on this webinar because you know that BI has power and promise. Some of you are really focused on using BI effectively today. But what we see and what a number of studies have demonstrated is that while BI is broadly used these days, we have a range of experience in terms of success with BI. And in fact, this Dresner study showed kind of our experience in the market, which is you get about 40% of the people saying that their BI initiatives are completely or somewhat available and successful, while about 48% only agree somewhat, and in fact 11% either disagree or somewhat disagree. So what we see overall is effectively kind of a split down the middle. A lot of people are finding BI very effective today, and a lot of people are still figuring out how to get the value from that. Now, there's a number of rationales and explanations for why that's happening, but we think one of the really important ones is incorporating analytical capabilities into BI that are very actionable. And that's, part of that is predictive-based analytics. So let's talk about that. And I'll start out with a success story. So one thing about Halo being working across the world, having many clients in different areas, we see success stories emerging from very interesting and unique places. And I thought I would start with one of a fishery down in Australia that's using Halo. And interestingly enough, they're using it on a dockside, right there on the docks, and they've built out a BI system that allows them to do a couple of things. One is understanding what sort of fish demand and loads are coming in from their fleets as they come into the docks. And by doing that, they get a faster take on the market in terms of actually understanding what types of fish are coming in and how they can price those. They also can work with their fleets more effectively to help the boats understand a number of quality issues, like how much spoilage is coming in of the fish they bring in. Did they not pack enough ice and packing materials to get back to the docks in time? It's a good example because what they've effectively done is identified several KPIs like revenue increases based on better pricing, reduction of waste, so figuring out which boats and what situations occur when they see more spoilage and helping to focus on that. And then overall helping the captains of those boats be more profitable, helping them understand exactly how they're performing relative to the other boats that are coming in. So a really unique and specific kind of vertical application, but of course you could take this whole example and turn it into a retail store or a manufacturing plant. Many of the dynamics are the same. One thing that is useful about this particular case, though, is their use of predictive analytics. And I thought I would walk through just a simplified example. And it's definitely simplified, but to give those of you that may be novices or don't have any experience and understanding of where the value is in integrating predictive tools. So in the world today, in BI, we typically start with a basic query. How are our boats doing? And here we might have the results of our small fleet of 3 boats. And we can see that they vary in terms of the amount of sales that are coming in off that boat for a year. Boat A is doing great. Boat C is a bit far behind. And as BI has developed, it's given us a lot more capability to do more Y analysis. And we typically call that OLAP or crosstab. It's taking those results and breaking them down in a number of filters or ways that we can look at it, try to explain what's happening. In this case, in looking at our fleet, we see something a little different, which is that boat A, while it's got the most sales, it's actually dropped over its prior period. Boat B is increased, and boat C is also increased. So if we were to look at those results, we might say, well, yeah, based on our scorecard here, boat B is actually looking pretty darn good. And those are 2 useful pieces of information. Typically, we may stop there. We might use our expert opinion, our experience to understand what we think is going to happen with our fleet and how we might improve it. The predictive modeling piece brings in a whole other piece of information, a way of looking at our fleet and thinking about it differently. So in this case, we've built a predictive model that we add on top of our BI. And it's important to note that predictive analytics is not a replacement for BI. It's merely that additional piece of information that better understands how we're doing and makes it more actionable. So in this case, you see our fleet of 3 boats. We see their actual sales as we saw, but we also see potential sales and the variance from that. And the potential sales is actually a predictive model. It's taking into account things about those boats and their experience, like their history, where they're located in terms of their fishing, that we call that a trade area in a retail example, what sort of competition or other boats are out there, and what the fishing conditions look like. And we can build a predictive model, allows us to say really where those boats are fishing, how there's captain and crew work and other factors. How good of a job should they be doing? Are they really doing a good job or not? And that allows us to put all those pieces together and be more strategic about our information. So before we knew basically how much they were selling, and we know how they did year-over-year period. We bring in our potential, and we might look at this in terms of what we might call a boat potential map. And a very simple way to think about it is with our boats, those boats that are actually bringing in a lot of fish and selling a lot and that have a high potential, they're fishing in rich waters, those might be called our anchor boats, those ones that are the core to our fleet, really doing well. On the other hand, those boats that are fishing and they're actually doing very well, but they're in an area where there's not that many fish, they might be overperforming. They're doing better than we might expect them to. And obviously those that are underperforming are those that have relatively low sales, but they're in a high potential area, a rich area for their fishing. So if we were to take the information we had and started plotting our boats on top of this type of strategic map, we start to get some interesting pieces of information. So we might look at it this way. Now our results are tipping a little bit differently. In this case, we would say, yeah, boat A, even though the results were down over the prior year period, they're an anchor boat. They have pretty high sales, and they should be doing well. Boat B, on the other hand, even though the sales were going up, they're still underperforming. We might want to look and see what we might do with that boat differently to get it to perform at a level closer to boat A. And of course, boat C, relatively low sales. They are going up, but reasonably, it's in an area where there's just not a lot of fish. Might we think about doing something different like that boat, like relocating it? So this is a way for us to start using our potential model to overlay onto the experience data that we get out of our BI system to think much more strategically about our fleet. And then bringing that back to maybe something that's more actionable is taking all this information and putting it into a scorecard. This might look more like a supplier scorecard, but in this case it's our fleet scorecard. And we brought some new information to what many companies typically would have. For example, how have they done in the actual period? How does that look relative to the prior period? We've had that. What is their potential range? Our model tells us where they fit relative to what their expectations should be. And then last of all, when we start thinking about sales prediction, how likely do we think they are that they're going to make their number in the next quarter? Another piece of information we bring in, not only how they did in the past, but a forward-looking view of how they'll do in the future. If we take and weight those type of factors, we can ultimately come up, first of all, with a prediction. How do we think they're going to do at the end of the next quarter? Well, boat A is probably going to continue to outperform. Boat B is underperforming, and boat C probably going to stay about the same. Based on that, what might we do? Well, of course, the outperforming boat, they're doing well. They're performing well. We might want to reward that boat. It might be a store manager, of course, that we're rewarding. An underperforming boat means they're not selling what they should be selling. So what's going on there? Is there something with the captain and crew? Is it something with the technology on the boat? We've now got information to help us pinpoint where the issue is. It's not that they're fishing an area with no fish. It's that they're doing something where they're not doing as well as they could be. And last of all, as we said, boat C has a rating of maintain. They're in a low fishing area. They're not bringing that much in relative to what we need. We might want to think about relocating them, relocating the area of better fishing. And of course, on a store example, it might be relocating that store to a higher opportunity area. So we've gone from a view of what's happened today, what the potential is, what's likely to happen, what our prediction is for the next phase, and then ultimately a prescription. And we've got the information now to make a more informed decision about what we think is going to happen. And of course, if you're the head of this fishery, you might have, if you have 3 boats, you probably know this kind of stuff overall, but what if you have 600 boats? Or what if you have 3,000 stores? It's this type of information that helps us quantify what we typically know about the experience from BI. It's helping us do a better job of consistently measuring, monitoring our stores, understanding really where the value is from data that we don't have access to typically from just using our BI system. And so then jumping back and you're getting a bit more serious and thinking about where industry lies today. There are a lot of different applications that most of you may be familiar with, from assortment optimization to fraud detection, marketing mix, supply chain optimization. These are typically the type of applications that require relatively sophisticated, expensive tools with specialists who are operating those tools. And what's really happening in the BI world today is through the advantages of open source technology, just the continued evolution of BI capabilities, we're seeing the ability to bring many more of these types of tools into the context of a BI platform. It makes them easier for all of us to use. And that means, unlike years past where mostly you would see Fortune 500 companies really leveraging these types of tools, we can bring it down to the small and medium-sized business as well. Now, within our world, we think about the value of this as being really packaged analytics for vertical markets. I think it's important to say that just having a generalized package, a tool of analytics is helpful, but really tying that to specific verticals is where we get the value. And on the left, you see a set of characteristics that we think about as being important when you start looking at this. From the standpoint of our perspective, we're taking the same approach that we took when we built our company, which is wrapping the Microsoft stack, but in this case, the Business Intelligent Development Stack, and putting that into a context where we're putting a wrapper, an interface around it to make it easier to access all those tools that are available in SQL Server analysis services, but are not that easy for everybody to access. And then also using open source tools like R. And R is a statistical package similar to, say, a SAS or SPSS, but it's open source. It's free, can be used by everyone. The only issue with it is it's generally a little bit hard to use unless you put some code around it, a wrapper, an interface to make it easy to access those tools. And the right-hand side is just a listing of some of the basic types of analytical algorithms that are available through both of those packages, and you see they're relatively sophisticated stuff, but at the end of the day, we're not so interested in that. We're interested in what we can do to leverage those tools to ask specific business questions. And within our view, with the Halo product, in terms of what we've done specifically, you see 10 different types of capabilities here that we've either integrated into our package or have rolled them out. There are things like a product analyzer, a product recommendation engine, and the closest analog is when you go onto Amazon, you buy a book that might recommend either a reading light, a bookmark, or 2 other books. That's effectively a product recommendation engine. But if you think about those, if you're selling products either to the end user as a consumer or maybe a manufacturer to retailer, you can think about using these tools to help you better figure out how to consistently offer a package of products that will maximize profitability. Again, the idea here is these look like relatively sophisticated tools, but they solve a very specific problem, and they're available now through a BI interface. So how do we do it? Not that much differently, frankly, than other people in the world that are doing it. Our approach is a little bit different in trying to really simplify the package. This is our Halo platform today. It includes data aggregation and enrichment. So we actually help build the data assets from your source data and make them ready for analysis. We then put in place reporting and analysis tools, and then ultimately a collaboration and dissemination platform. So this is today kind of the 3 rings of a really full BI practice. And all we've done is taken and we've added on to that capability a predictive engine. So it's another component of this overall platform. And when we have this in place, what do we get? We get this added functionality of a predictive model, which allows us, number one, to have tools that allow you to build a model, and it might be a predictive model or an optimization model or a prescriptive model, and those sound complex. Well, you have the tools to do that yourself, but if you don't, we've also packaged those completely, and this is not unlike other people have done too, to allow you to just pull those models and use them against your data without a lot of advanced data science requirement to overlay on top of that. And then second, all that analytics can be used either for your own decision making, so many companies have tool capabilities where they have just their business analysts on staff and even decision makers who use these tools to make day-to-day decisions for doing things like supplier reviews through scorecards or maybe doing profitability analysis on their products. And then last of all, same information is often used to derive business rules, so they use more indirectly by putting intelligence back into your core systems like your ERP or CRM to do automated types of analysis. One of the real values of predictive is in terms of helping make better, consistent, small decisions every day in your operational systems. And those might be things like detecting transactions that are coming across that may be fraudulent, or identifying through alerts things like when product margins are slipping and notifying managers when that happens without having to have an analyst do that every day. So this is the core value of predictive here, adding it to the BI situation. And then last of all, I'll finish up with a quick case study before turning it over to Drew to kind of make this all real. This is an example of in a retail situation where we can take predictive analytics in the context of BI and do 3 main things. 1, we can focus on our supply chain. 2, we can focus on our customers. And 3, we can look at product level profitability. And it's all kind of coming from the same general source of data, but we can do a lot of sophisticated stuff in a real easy manner. In this case, we're taking data out of the Dynamics AX platform, all the POS data, inventory, procurement, and shipping. We want to be able to analyze that data and look for cost savings opportunities in our supply chain. And there's different approaches we can take. In this case, there are tools like principal components analysis, linear programming, which they're baked into the back of the BI system. So as long as we choose our business questions carefully and look at our results carefully, we can use these with a high degree of automation. And we can do things like, first of all, look at optimizing our inventory, looking at and anticipating future demand through our predictive tools, and really looking at what's the optimal product per store safety stock recommendations. And you turn that around, we can also look at it in terms of, what's the optimum transportation cost that we can develop for our store network by looking at our shipping routes, origin, destination information, our truck capacity, and our costs for each trip. These are all the types of things that they're relatively complex if you have a person doing it, but when we bring in computers, we can start to look at all these complex dimensions, bring them together in relatively simple types of analysis to make recommendations to us as what's the best way to get our products from their source of distribution into our stores, and then what's the right amount. And taken together, these are the types of applications that can yield significant per store profits if we focus on any particular one of those areas, all from a common predictive analytics platform. A second focus area is on marketing. So first we looked at our supply chain, but really leveraging similar data, say out of our dynamic CRM system, and we can enrich that data with any other predictive information we might have, like household demographics attached to a consumer file, and use predictive tools to understand, kind of like we did in our fleet example, what our customers look like. Ideally, we'd like to rank them based on their value to our business, but that value can be based on how they've done with us in the past. If they typically bought a lot from us, if they bought frequently, do they buy our high-margin products? But as most of us know, past behavior is not a clear indicator of future performance. So what we might want to do in bringing in analytics here is look not only at their past history and potential, but also their future. What's their future potential value in terms of the products they bought and the other new products they might buy from us? So by blending those two pieces together, we can take and create a view of our client base and our customer base. And so, for example, we might say as a retailer, I've got a whole segment of low-value customers out there, but they should be high potential. They look like my other high-value customers, maybe in terms of their demographics, their financial profile, or in terms of the products that they've begun purchasing and how they're visiting my store. By developing a model allows us to basically rank and sort those low-value, high-potential customers. That gives us a lot of information then to start directing and coordinating some of our marketing movements. So, for example, we might look at them and say, okay, what are the next best set of products that we would want to market to them? If we do want to do that, what's the best channel to reach them? Should we be reaching them by mail, by email, through social media when they come into the store? All the types of analysis that further, more predictive analysis helps us focus on. And when we do that, we can see through coordinated marketing campaigns and monitoring the results that we can generate significant returns within those particular types of segments. As long as we've been specific about what that segment is and how we're going to approach it, we have a very good way of quantifying the value of our marketing dollar. And then third and last, taking the same approach with predictive intelligence, that's taking the predictive and putting it into the BI platform, is thinking about profitability. In this case, we're thinking about shelf space profitability. And that basically means understanding at a product level how much sales are flowing through our store at a store level, as well as that store cost per square foot. And what we can do in this situation is basically allocate those sales over the shelf space allotted to that product. That gives us a better understanding of really what's the product level profitability. How much are we spending to get that product out the door? And then the type of analysis we would look at is, we might call outlier analysis or threshold analysis. And what that's really doing is just looking at that margin on profitability, or the variation in the margin on our products, characterizing those and sorting and ranking those and saying, okay, which ones are giving us a lot of margins and which ones aren't. And we have a couple of decisions to make with that new information. One might be simply trimming low-margin products, or if they're important, we're not going to trim them. Maybe looking at how we're doing our discount and promotion programs and reducing that on low-margin programs and moving them towards the high-margin products. We can also do many things within the store. So, for example, for high-margin products, we might want to give them the ideal space on the shelf and on the aisle. And taken together, these are results that would be typical for a large retailer as well as a mid-sized retailer. We can often find that we can put a smaller number of products in our store without much impact at all on our margins. So these are three core examples of taking the same BI, PI, predictive intelligence approach, and then allocating these types of applications using statistical analysis in our BI systems. Now, in summary, we've covered a fair amount here, but I'm going to turn it over to Drew, and we're going to talk a little more about specifics. But our main points here is that every economy and market is more data intensive, whether it's a fishery or a retailer. BI's limits are not really technology, but our results show us that not everybody is getting the value out of it. And we think one of the key areas is that many times BI lacks context and actionability. We can understand really what's happened in the past through our KPIs, but sometimes the best measures are those that we don't know about today that tell us something about the future. And we think predictive analytics and scoring capabilities really create that actionability. And then last of all, predictive intelligence must really sit on top of operational systems. If it stays within relatively separate high-end data science shops, oftentimes that all that value doesn't get translated out to the business. It doesn't get implemented easily. So with that, I'm going to turn things over to Drew. I think we have one more poll, and then we're going to get down and talk really specifically about how you would actually accomplish some of this stuff.
All right, thank you very much, Keith. Our next poll question, if you'll bear with me just a second here. Should be seeing that come up on your screen here shortly. So the questions there are, what are your thoughts? What are your thoughts on predictive intelligence in your organization? And you can just select the answer there that makes the most sense to you on the screen. And we'll share those results in just a moment here. And it looks like it's pretty much a tie for PI making sense, but facing challenges in your organizations. 41% have answered that, and 58% answered that PI is a viable approach for their organization. Only 5% said they have no plans or no needs for predictive intelligence, which is interesting. All right, and with that, I think we'll go ahead and turn the presentation over to Drew Minkin.
Thank you, Kitty. So I think by now everyone understands the significant business value for predictive intelligence. But the question maybe remaining is that, this is all great. I understand this is complex, but how can my organization, with me being a David more than a Goliath potentially, or just, trying to do Goliath things with a David budget, if you will, be able to accomplish such wondrous returns on investment. And so before I introduce the offering that we have and help you understand and see it in action, I want to make sure that you understood from a big picture standpoint why we think that predictive intelligence is the way to really think about it, and what types of technologies we're building into our business intelligence platform. So when you look at the actual buckets of technology that are involved in a business intelligence solution, you can boil it down to these less than a dozen real technology groups. You can split hairs on different details of what integration is and other things, but in essence, these are the surfaces that people know and either love or are at least embracing as business intelligence today. But when you look at business intelligence from an analytic perspective, you're generally easy pickings as far as finding the stuff that sticks out like sore thumbs. It's easy to sort and slice and dice to be able to see outliers, to be able to apply Six Sigma type things. But when you look at that type of lens and visit your problem, you end up only really seeing the outliers, if you will. And a lot of times, problems are much more complex than that. So we need to do a little bit more than that. And from another perspective, just architecturally and business-wise, there's a lot of questions that business intelligence just can't answer well. One is, did we know what we need to do in time? Is there a way to be able to anticipate this? Or do we know when we could intervene or where we should intervene? What are those sweet spots? Can we prevent problems in the future? And sometimes the hardest question is, what is the value that we got from our PI project? So flipping the other side, and you can see when you look at the model production side that there's very little that's directly related to the predictive analytics process. I put big data in here, even though it's not necessarily a part of predictive. They've been doing logistic regression since World War II. But I would argue that the number one reason to do big data is because you want to have interesting information to enrich the operational data that you already have in order to be able to look for patterns that would not be obvious if you didn't blend those data resources together. So you have model production and model consumption. Data mining and data science a lot of times really doesn't care about model consumption. That's an operational piece. And so the predictive analytics is considered an innovation because it extends these model building from PhDs or people with very deep technical statistical backgrounds to be able to share those models with an organization. But even predictive analytics has its limits because you don't necessarily have a good model from a business standpoint if you don't know how to make the predictions themselves actionable. It's also sometimes difficult to understand from a business perspective when to refresh a model, how to get the best ROI, and whether you're tracking towards it or not. And also, are there ways that I can improve the model? Are there cold spots where it's just not reaching or doing the things that we would expect, and what changes have happened in our world since we made the model? So taking a step back, it's important to understand that a lot of what happens when people do data science is that they start from scratch. They just get raw data, they build a one-off structure that suits the purposes of their analysis, they turn in a model, and then they leave it to somebody else to be able to figure out how to get the benefit out of it. And sometimes that observation is enough. But in general, if you want to be able to do true predictive analytics, in order to be able to understand how a model is doing, how the model is performing, when it's not working, and who it's not working for, you need to be able to integrate that and monitor it. And a lot of that is really business intelligence. So if you don't have business intelligence infrastructure, you end up duplicating a lot of effort, and you end up not being able to get it back in the hands of the business so that they know how things are going. So you can really argue that the majority of the work that you do to invest in the business intelligence infrastructure is a precursor to what needs to be done for building models here. But the benefit is significant for a very small investment a lot of times with models. So now that we see that they are really something we should consider in tandem, and you look at the overlaps, it becomes clear that there's really only a narrow set of technical tasks that we need to automate and be able to make business friendly in order to make predictive analytics a lot closer to business intelligence. And you can see that since a lot of those technologies are in business intelligence, we think that rather than trying to be a business intelligence technology that is independent of predictive analytics or a predictive solution that leaves business intelligence to somebody else, that since most people understand data best through business intelligence, that we want to create a window into that world through predictive intelligence. So you can look at the union of all these pieces as predictive intelligence from a nitty-gritty standpoint. So now that we understand what predictive intelligence is from a business perspective and from a technical perspective, how can Halo help your organization? What are we actually going to be delivering that will make this easier for you? So we've looked very hard at the market and tried to identify the places where we see that data science is not really delivering on the promise. Now, the big guys can always do data science because they can have problems that are big enough that they can always justify having very expensive resources, take long periods of time to handcraft every single model. But we're not looking. The pace nowadays is that we're not trying to look for cuckoo clocks that are handmade to be able to tell the time of our business. We want to be able to have a digital clock that we can just mass produce, if you will. So we're trying to address 4 major concerns about resource that are primarily around resource allocation, but also it's not just getting bodies, it's getting the bodies that are smart enough to do what needs to be done. And we would argue that there's a lot of things that are done manually and serially by data scientists that we can make parallel and instrument as good software in order to be able to make the technology leap and allow your business to make that business leap, particularly when we focus on trying to take our best practices from experience in price optimization and all sorts of other detailed domains for predictive and give you package solutions that all you have to do is map the data and have models ready within weeks instead of months. So in order to understand the pieces of our predictive intelligence offering here, I just wanted to review that there are 3 pieces that are our core product that Keith introduced earlier. But for purposes of our architecture, I wanted to introduce to you the names of our individual components. So we have Source as our one-stop shop for all of our integration and aggregation needs. Essentially, if you know SQL, you can build packages that are taken care of for you once you build the mapping, and the cubes are built automatically for you from the same tool within a fraction of the time of what it would take you to do it manually, even if you have deep BI skills. And then Prism essentially eliminates the need to hand build reports and is a great dissemination platform. But beyond that, if you want to extend your analytics value to your ecosystem of suppliers, distributors, and even directly to customers, then you can share those with a single sign-on with our STAN product offering. And so now that you understand these particular components here, it's going to be easier to understand how we break down predictive intelligence. So kind of following some of the standards on when people break down advanced analytics, first we'd want to talk about descriptive services. And in future webinars, we will be discussing these in more detail. But you can think of it as essentially using our Prism tool to be able to not only access models and create models, but to be able to add different values, things that are statistical, sort of nitty-gritty things for changing distributions or aggregating data. But again, since a lot of the times there may be data sources that are only being used for the predictive model that may not be part of your enterprise architecture, then you can bring those in and clean them up with us. Or you can even use our tools to help with lightening the enterprise responsibilities of data quality by making it a democratic process through our web client. So, you know, there's the highest overlap between BI and predictive and the descriptive piece, because a lot of the descriptive is BI, but and we add certainly a lot of value in automating the tasks that normally are done by hand for data scientists here. And then when you look at predictive services, there's kind of two major aspects to it. One is being able to arrive at the model that we like best, and this is where the heavy lifting of using machine learning algorithms, you know, things with the fancy names like neural networks and support vector machines, and all that kind of fun stuff to be able to get very complex math to extract simple observations and patterns that can be understood by the business to be able to advance your efforts there. And a lot of times modeling and predictive tools stop there, but we consider that a model is really not valuable unless it's been integrated into your enterprise data, because you're starting from looking at BI views, you expect to experience everything with BI views, so there's no reason not to tie everything back to your enterprise data. So, you know, if you've done a customer model for segmentation, you're automatically going to be able to see how that applies based on, you know, regional and operational pieces that may not even be included in your model. And finally, once you have a predictive model that has error rates and you're going to be used in production, we build the entire infrastructure for you so that you have essentially templatized the ability to understand how my model is doing, what populations they're doing good and bad for, and give you ideas and alerts on when things should potentially change to refresh the model and potentially add new variables there. And finally, models from a top-down view can be very powerful, but the main thing is to try to get them out to as many people as possible so that they have the highest impact across the organization. And so one way is to be able to just share those not only internally, but in aggregation with the business ecosystem so that people can get personalized forecasting for their products or you know, their suppliers, or to be able to give people a context of, you know, where they fit in as far as different communities within the customer population. So, but you can take that a step further and think of the models themselves as a standalone intellectual property that you can deliver and be able to have people integrate into other applications. And that's where scoring services come in, so you could essentially build your own credit risk model and just be able to publish it as a web service internally, or use one of those web services and its JSON over REST interface to be able to embed it in an analytics application so that you can extend the reach beyond traditional BI and put it directly into your transactional and operational hands very quickly. So with that, I'm going to introduce you to the Halo Advanced Analytics sneak preview here. So what you see here is a view of our Prism here, where we have a series of sales officers over different territories, and we can see the different predictions that we have and their different status as far as what we're expecting. If we look at Mr. Longstreet here, our our forecasting model has said that we expect him based on his projections, based on where he is in the market and potential to be able to go further than what we see extended from his last 9 months of sales. So we see that there's actually a gap or an expected shortfall from his target of 17% here. But when we look at another model to see what are the biggest contributing factors to being able to influence monthly revenue, we see that market share is the biggest one. And we can see that his market share is 46.23% here. And based on the market share range, that's pretty low on the scale. So we think that with a little bit of marketing and some additional sales that we might be able to actually get him to go up to 75%. So let's go ahead and hit preview. And what we're doing here is we're now taking this recommendation and it's been written back into the cube. And now we can refresh to see what we see is going to be the impact for his projected monthly revenue. So now we see that now we're not going to have a shortfall, but he's actually 65% above plan with a 75% mark. And so this is one example of the types of prescriptive services that you would have it interactively. For other types of models, you may look at localized scores for risk models and other things that you may be able to want to give feedback to the model directly from your business intelligence view. So behind the scenes, you would normally see everything for model using our source tool. And so this is an example of a source project where we have a wide variety of data sources that are available for you to integrate. And these are all going to be available from Prism plugins for you to be able to just follow web wizards to be able to generate the models. And behind the scenes, what they do is they actually generate transforms that will be able to connect to the model, whether it's coming from Microsoft SQL Server, or whether it's coming from R, or whether it's a combination model where we may use some parts from SQL, some parts from R, or build other complex structures where we've baked in other types of tweaking that's been done within the web UI there. And so once you have those pieces ready, you can then be able to have access to, from a what if analysis here, to market basket analysis. So what we have here is a core diagram where you can see major lines of our products here. And to help you understand this, you can look here, and microwave ovens really don't influence a lot of other products. You can see that we see most transactions, the majority of them are with microwave ovens by themselves, and there's not a lot of influence between microwave ovens and other purchases. But if we look at kitchen whiteware, we see that kitchen whiteware, even though it's a small percentage of our sales, that we see that people come in and don't really buy computers from us unless they're buying kitchen whiteware as well. So that tells us that we can use kitchen whiteware discounting as a loss leader to be able to bring more people into our stores for computers sales to increase. And so from there, we can also combine this with market segmentation in order to be able to create segment-aware logins. So for example, you can see that Ariana Gonzalez has logged in and is gadget crazy, so she gets a certain set of recommendations on a product. Whereas Jerome Romero may be an occasional splurge, so he's going to get slightly different recommendations for his products there. And so at the end of the day, we see that our approach to predictive analytics is unique because we are investing in our years and years old HTML5 infrastructure to be able to allow people to build models mobily. And when those models are built, they're automatically integrated into your business intelligence infrastructure. So there's no need to have another Netflix $1 million loss on a model you can't integrate. And then all of the data quality and visualization pieces that you would normally use for BI are available to use for predictive and then some. And then once you like a model and you want to share it more, we give you ways that with a few mouse clicks, you can generate web service to be able to help people. So with that, I think that we are ready for questions. So thank you very much.
All right, thanks everybody. Well, as we start to submit your questions, Drew, why don't you pass controls back to Kitty, and we'll wait a few minutes to see if we have some questions come up. I think we want you to go away with kind of 3 points. One is that BI has been very successful, but really be accelerated and adds a lot of value when you incorporate the predictive component. 2 is that predictive analytics provides a lot of actionability, but is not really available through just core BI today. It gives us much more ability to be prescriptive from the analysis that we have. And then 3, we're in a relatively unique time period where many of the tools that have typically been the domain of kind of high-end analysts and statisticians are now becoming much more available through tools like business intelligence platforms. And so we expect, and we are definitely focused on bringing more of these predictive tools to market in the context of core decision-making platforms like Halo's BI platform.
So we do have one more poll question we'd like to ask everyone of our viewers here, and it's basically how you would like us to follow up with you. And you're free to check all of the boxes there that apply. If you'd like a copy of the presentation, we'd be happy to email that to you. Or if you'd like us to send additional information about our predictive intelligence and advanced analytics offering, we'd be more than happy to do that. And finally, if you'd like to schedule a live demo where we can go into more depth and also talk more specifically about your particular organization's use case, we would be happy to do that as well. So feel free, once again, to select all of those that are of interest to you. And with that, we are going to close the poll and see if we have any questions here, if anyone submitted any questions. And let's see, it looks like we do have one here. How long does it take to get predictive models up and running? Would you like to take a stab at that, Keith?
Sure. Or actually, Drew, you want to start with that one?
Yeah, that's fine. So, just to give you some background, when we approach a business intelligence implementation, we generally measure results for finished ETL and cubes, data warehouse, all that good stuff, end-to-end, within a 2 to 3 week period, because that's how fast Source and Prism are in being able to give BI value. And we've extended essentially the exact same type of value proposition. Say, look, if you've identified your data and you've got a question, a hard question you want to ask, or one of our modules that are ready to go on it, then we would expect that within the first 2 to 3 weeks that you would have a model that would be ready to be able to put into production. So certainly every model is not etched in stone in that generally you want to look at monitoring because you may revisit it every 6 months. It may be something every 1 month that you want to look at. But essentially to be able to get business value that's ready for production, it's something that we measure in 2 to 3 weeks. Certainly for more complex questions like doing pricing optimization or supply chain optimization, what you may see is that we have initial component models that are available within the first 2 to 3 week iteration, if you will, and then generally we can have a full solution within another 1 or 2 of those iterations. And keep in mind that's with the idea that there's usually a virtual team of about 3 people, one of them being the business intelligence person and analyst building models, and then the people that are doing support and the business owners themselves. So
great, Drew. Thank you very much. We do have another question here. Is anyone using predictive analytics with HRM data to improve hiring / reduce turnover, et cetera? Keith, you want to take a stab at that one?
Okay. Yeah, sure. Human resource management systems have a ton of data about employees in them, and there is a lot of work that goes on. I think it's really emerging in the area of either recruiting, hiring and staffing, or more workforce analytics in terms of productivity. One of the common ones that we have seen is in looking and assessing risk for employees. Which employees are at risk of quitting or leaving, and why is that the case? Another type of example would be in terms of performance or potential, taking a historical view of your data to look at which employees have performed well and how much farther they might go in certain positions in your company. I do know that Google, for example, says when they're hiring college graduates now, they don't even really look at, say, standardized test scores and GPAs coming out of high school or college. They use more behavioral data, and then they've culled through their vast repository of information to build up algorithms that would suggest a good fit for a particular employee and how likely they are to contribute to the firm. I know they look at specific dimensions they've developed through their data, like their kind of cognitive flexibility and their fit, their motivation for that type of culture. So good examples of very analytically driven approaches to human resource management. And the other one I think is more in terms of workforce analytics. So if you're a shift-based business like a fabrication manufacturer and you're trying to optimize your shifts, part of that definition is often how you run a shift, but also how you staff and compose a shift to get maximum output. That might be building up really strong shifts with your best and most experienced people, or it might be seeding them into specific teams to help them drive more productivity through those teams. So those are, I think, specific examples, and I know that there is a lot of interest and focus on leveraging the data. That the key is in those is typically ideal for companies with lots of employees and lots of history, so they can build those good types of analyses. And smaller businesses sometimes don't have that same breadth of data to work with.
Thank you, Keith. We do have a number of other questions. Unfortunately, we are at the top of the hour, so we will be following up with those of you that have submitted questions we weren't able to get to after our webinar. Meanwhile, we have displayed on the screen there our contact information with Keith and Drew's information there as well. So thank you all very much for attending today's session. We hope you got a lot out of it, and we look forward to continuing the conversation in the near future. Have a great day.